Okay, so here we're looking at translating functions. So it's really just looking more at the notation of how we translate a function on our Cartesian plane. We want to do this still because it's just the notation that we need in order to move forward further in the methods course. And your success criteria here are you want to be able to understand the notation of x dash and y dash and be able to convert a function to its translated form. So our Cartesian plane, remember, is just our axes. It's all our x and y values. It's represented by the set of all ordered pairs of real numbers. So we can identify any point on the Cartesian plane with an x and y coordinate. And we call that set of ordered pairs of real numbers r squared, so the real numbers squared. So you can see that set notation, we're saying that the set of all the ordered pairs of real numbers is the set of x and y such that x and y are both real numbers. We can make a translation of any ordered pair by identifying how we move that point in our x and y axes. So if we wanted to say 3 units to the right, that'd be 3 units in the positive direction of our x-axis. That's going to associate the point xy with a new point, so the point we're translating to, of x plus 3y, which is what this particular graph here is showing us. So each one of these points has been moved 3 units to the right on our x-axis, and the y has stayed the same because we're not translating the y in this case. When it comes to the notation of this, we would read this as the point xy maps to x plus 3y. So that's what that little arrow means, saying xy maps to x plus 3y. We would refer to the new point as x dash y dash. So that's where that little piece of notation comes in. So in this example, we would have the point x dash equals x plus 3, our original x point plus 3 units, and y dash is still equal to y. So the rule in this case, the translation of points in the x and y axes can be described by the rule that the point xy maps to x plus or minus h and y plus or minus k, where h and k are positive numbers. So you'll be kind of thinking back to when we did translation of quadratics, that when we're in turning point form, we've got h and k giving us our x and y translations. This is the exact same case. So if we want to actually apply that translation to a whole graph rather than just one point on our Cartesian plane, let's say we want to translate the function f of x equals x squared, so our basic parabola, 2 units right and 4 units up. The way that question might be phrased would be something like, translate the set of points defined by the function that's given here, so it'd be the set of the points of xy such that y equals x squared. So saying in every pair of numbers, your value of y is given, will then be the square of your x value. And it's by the translation defined by the rule xy such that x plus 2, y plus 4, or maps to, rather than such that x plus 2, y plus 4, which could also be written as x dash equals x plus 2 and y dash equals y plus 4. So for each point xy, there is going to be a unique point x dash y dash for this particular function. We can rearrange this translation that's happened to say that x is going to equal x dash minus 2. So we're just subtracting 2 from both sides, rearranging, and y is going to equal y dash minus 4. Now, if we think of our original equation here, y equals x squared, what we're doing effectively is now substituting in these values of x and y to talk about where that translation is. So the equation y equals x squared maps to y dash minus 4 equals x dash minus 2 squared. Okay, so to write that back in our set notation, we have that the points xy such that y equals x squared maps to the point x dash y dash such that y dash minus 4 equals x dash minus 2 squared. Okay, if we were to graph that, it would look something like this. Let's move that down. Okay, so all we've done, you can see we've got our basic original parabola x squared. We've moved it 2 units to the right, so our vertex has moved from 0 to 2 in the x, and 4 units up, so it's gone from 0 to 4. So if we think about if we were writing that in turning point form, you would actually have y equals x minus 2 squared plus 4. So it's the exact same thing, just that 4 has been moved over to the y side. So our translation, it's just a different way of writing that same translation. So if you can start to recognize those things in some functions that you already know, then it'll start to get a lot easier. So looking at another example here, we want to find the equation for the image of the curve, so just the translated curve, where our equation is y equals f of x, and f of x equals 1 over x. So we can just think of that as y equals 1 over x, remember. Our translation is going to be 3 units in the positive direction of x, so 3 to the right, and 2 negative in y, so 2 down. So our rule, we know that xy is going to map to x dash y dash. So instead of writing x dash y dash, we're going to write that it's going to x plus 3 y minus 2. Okay, so our rule is that xy is going to map to x plus 3 y minus 2. So we can say that x dash is equal to x plus 3, y dash is equal to y minus 2, and then we can rearrange those so that they're in terms of x and y rather than x dash and y dash, so that we can substitute them back into our equation. So x is going to be x dash minus 3, y is going to be y dash plus 2. So subbing these back into our equation, y equals f of x, we would just say, so y equals f of x is going to map to y dash plus 2 equals f of x dash minus 3. We can also map it to y equals 1 over x. If we wanted to do that, y equals 1 over x is going to map to y dash plus 2 equals 1 over x dash minus 3. We can't map it to exactly to f of x equals 1 over x. So even though both of these equations mean the same thing, if we map it specifically to f of x equals 1 over x, then all we end up writing would be that f of x dash minus 3 equals 1 over x dash minus 3, which doesn't tell us how much we've been translated in the y-axis. So we need to make sure that somewhere in our newly mapped equation, we're making reference to that y translation. You could write that y dash equals, I'll write this, f of x dash minus 3 minus 2. That would work perfectly. You just need to make sure that somewhere in your equation, you've got reference to that y-axis translation.